Section 2.7 is about combining functions. So what we're doing is we're taking old functions and we're finding ways to algebraically create new ones, okay? So some arithmetical operations with functions. Suppose f and g are two functions. Then the sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f over g, are functions defined by the following equations. F plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. F times g of x is equal to f of x times g of x. And f divided by g of x is equal to f of x divided by g of x, provided that g of x is not equal to 0. The last part just means we cannot divide by 0. That's what this part means. Okay? So example 1. Suppose f of x is equal to x squared plus 1. And suppose g of x is equal to 3x plus 5. Let's find each of the following. Let's find f plus g of 1. So that's equal to f of 1 plus g of 1 using our sum rule. But what's f of 1? That's f of x. F of x is x squared plus 1. What's f of 1? 1 squared plus 1. Good. Plus g of 1. What's g of 1? 8. Good. So you'll have 2 plus 8, which is what? 10. Good. F minus g of negative 3 is equal to f of negative 3 minus g of negative 3. F of negative 3 is negative 3 quantity squared plus 1 minus the quantity 3 times negative 3 plus 5. Negative 3 squared is what? 9 plus 1 is 10. Negative 3 times 3 is? Negative 9 plus 5 is? Negative 4. So minus a negative 4, what do we get? 14. Good. F times g of 5, that's equal to f of 5 times g of 5. We're using the product rule. We're using this one. So that's equal to f of 5 is what? Which is 26. Good. So it's 5 squared plus 1, which is 26. Then we're going to multiply that by g of 5. G of 5 is what? 20, right? Because you plug 5 in or substitute 5 in here. 5 times 3 is 15 plus 5 is 20. And what is 26 times 20? 520. Good. Now, f divided by g of 0 is the same thing as f of 0 divided by g of 0. What's f of 0? 1. And what is g of 0? 5. So we get 1/5. We get 1/5. Okay? So now what we've done is we've taken two different functions and we've created new functions. The sum, the difference, the product, and the quotient. Okay, now what we're going to do is we're going to talk about the domains of those new functions we introduced. Okay, the domains are the x value. The domain is the x values for a specific function. Okay, so keep that in mind. Now, let f and g be functions. with domains A and B respectively. The domains of f plus g, f minus g, and f times g include all real numbers in the intersection of the domains of f and g. That is, the domain is A intersect B. A intersect B. So it's what they have in common, where they overlap. Okay, where they overlap. The domain, does that make sense? A little bit. So if the domain of A is, or the domain of F is -1 to 2, if that's the domain of F, and the domain of G is 0 to 1, 1. Where do they overlap? Just 0 and 1 separately? 0 through 1. So the intersection, so A, so remember that was the A and this is your B. A intersect B is the closed interval 0, 1. It's where they overlap, intersect. Okay? Does that make more sense? Yeah. Okay. The domain of F divided by G includes all those numbers, real numbers, in the intersection of the domains of F and G for which G of X is not equal to 0. So in other words, it's the set of all X in A intersect B such that G of X is not equal to 0. Okay? So let's look at some examples. Example 2, we're going to let f of x be equal to 8x minus 9, and then g of x is going to be equal to the square root of 2x minus 1. For this problem, it suffices for us to know the domain of f of x and the domain of g of x, okay? Because what we have to do is we have to find the domain of f plus g of x, which by this first bullet says it includes all real numbers in the intersection of the domains of f and g. Okay? So the domain of f of x is what? It's the domain of f of x. All real numbers. Good. So that's negative infinity to infinity. The domain of g of x you have to write out a little bit. So the domain of g of x is the set of all x such that 2x minus 1 is greater than or equal to what? When you're talking about a radical, the radicand has to be what? Positive or equal to 0, right? So we can say greater than or equal to 0. So this would then be the set of all x such that 2x is greater than or equal to 1. So we added 1 to both sides of that inequality. And now we divide both sides of that inequality by 2. So that's the set of all x such that x is greater than or equal to 1/2. What is that in interval notation? You want it? Say it. What is that in interval notation? Okay, so this is equal to, the domain of g of x is equal to bracket 1/2 to infinity, and you have a bracket because you have equal to here. So that means you include it. Okay, so here, for the domain of f plus g of x, we want to intersect all real numbers with bracket 1/2 to infinity. What is the intersection? So what is negative infinity to infinity intersect bracket 1/2 to infinity.
From 1/2 to infinity.
Bracket 1/2 to infinity. That's where they overlap. That's your answer. That's the domain of f plus g of x. Now, in part B, we want to find the domain of f over g of x. So notice when we go back up here, it said it includes all those real numbers in the intersection of the domains of f and g for which g of x is not equal to 0. What value makes g of x equal to 0? One half, good. G of x equals 0 when x is equal to 1/2, so that means we have to exclude 1/2 from star here, star star. When we exclude 1/2 from star star, what is our interval? What is our interval now? So now we're saying do not include 1/2. So now you should say what? So if we do not include 1/2 here, how do we write that in interval notation? It would now be parentheses 1/2, comma, infinity. That's how we say do not include the number 1/2. Okay? What questions do you have? Okay? So another type of function that we can create is that of the following. So let's start out with the definition. Given two functions, f and g, the composite function f circle g, also called the composition of f and g, is defined by f circle g of x is equal to f of g of x. This is read as f of g of x. Okay? So, for the next examples, what we're going to do is we're going to find the functions below and we're going to find their domains given the following. F of x is equal to 1 over the square root of x, and g of x is equal to x squared minus 4x. So here, f circle g of x is f of g of x. G of x is x squared minus 4x, so this is f of x squared minus 4x. And this means we take x squared minus 4x and substitute it in for x for f of x. So this would then be 1 divided by the square root of x squared minus 4x. Does that make sense? You processing? You need a minute? All right, so what we did was we took g of x, substituted that in for x and f, and this is what we ended up with. Now we have to find out when this is defined, okay? So this is defined, meaning we need to find out what its domain is. So here we have this is defined, the composition is defined when x squared minus 4x is greater than 0. Okay, we have to exclude where it equals 0 because we cannot divide by 0. Okay, So that means x times x minus 4 has to be greater than 0. The only way that happens is if we have x, oops, I didn't mean to do that. I want to use the highlighter. That only happens if x is greater than 0 and x minus 4 is greater than 0, or if x is less than 0 and x minus 4 is less than 0. Does that make sense? Again, one more time. The only way this product can be positive is if x is positive and x minus 4 is positive, or x is negative and x minus 4 is negative. So that means that we get negative infinity to 0, union 4 to infinity. So that's our domain, and this is our composition. Okay? So now, with G composed with F, we get, that is, do you have a question?
No.
Oh, okay. So that's G of F of X. F of X is what? What's F of X? 1 over square root of X. So now we're substituting that in. Good. We're substituting 1 over square root of X in for X in G of X. So that gives us 1 over square root of X quantity squared minus 4 times 1 over square root of X. That's equal to 1 squared over the square root of X squared, which is just 1 over X, minus 4 over the square root of X. Okay? So now we need to find the domain. This is defined when X is greater than 0, right? We cannot have a negative underneath the square root here. So X has to be greater than 0. What is the interval that corresponds to that? So if you want to say that X is greater than 0, so this is defined when X is greater than 0, or in other words, you have all of this on your number line. Open circle at 0, everything to the right of it. How do you write that in interval notation? Yes, parentheses 0, comma, infinity. If you are visual, which you're responding after you draw the number line, draw a number line. Draw a number line. We talked about inequality notation, interval notation, and we drew a number line. You have to practice it. I can't make you do it. You need to know it for this. It's all coming back. Yes?
Where'd you get the X is greater than 0? Like, where's that coming from?
X greater than 0. That's coming from the fact here. Notice that X cannot be equal to 0. We have to pay attention to our denominator for rational functions to figure out what numbers we have to exclude. The square root of X only makes sense when X is greater than or equal to 0. But can we have 0 here? Can we divide by 0? No, so we cannot include 0, right? So X has to be strictly greater than 0. That's where that's coming from. Okay? Now, let's find the last two. We have to find F composed with F. So, that's equal to F of X. And that's equal to F of 1 over square root of X. That's equal to F of 1 over square root of X means now we're taking this entire thing and substituting it in for X here. So we get 1 divided by the square root of 1 over the square root of x. That's the same thing as 1 divided by the square root of 1 divided by the square root of the square root of x. So now we're taking 1 and we're dividing it by a rational function itself. So that means we take 1 and multiply by the what of this? One divided by a rational function. So an aside. One divided by a over b is the same thing as 1 times what? Say it loud. No, not AB. B over A. Dividing by A over B is the same thing as multiplying by the reciprocal of it. So you just get B over A. So, with that said, we apply this concept to this. So we get, this is equal to the square root of the square root of x divided by the square root of 1. The square root of the square root of x is the 4th root of x. And divided by the square root of 1 is just 1. So we get the 4th root of x. Okay. And when is that defined? This is defined when? Good. When x is greater than 0. Interval notation, what is that? Parentheses 0 to infinity. Good. That's it. That's the domain of f composed with f. Okay? Now let's do G composed with G. Let's not make random marks. Let's do G composed with G. Remember, G of x is equal to x squared minus 4x. So that's G of G of x. That's equal to G of x squared minus 4x. So now we're taking x squared minus 4x and substituting it in for x here. So we get x squared minus 4x quantity squared minus 4 times x squared minus 4x. So now we have to actually square x squared minus 4x. When you square that, what do you get? Talk a little bit. X to the 4th minus 4x. Careful. You have to remember your middle term and your outer and your inner term. Remember, so on the side here, you have x squared minus 4x times x squared minus 4x means you have to multiply the first terms. You get x to the 4th. The outer term, you get minus 4x cubed. Your inner term, you get minus 4x cubed. And then your last term, you get plus 16x squared. So remember your inside and your outside. Okay? So we get x to the 4th minus 8x cubed plus 16x squared minus, now you have to distribute your negative. You have to distribute your negative here. Negative 4. So you get minus 4x squared plus 16x. And simplifying, we get x to the 4th minus 8x cubed plus what? 12x squared. Did we do all of that right? Yeah, we did. Okay, and then plus what? 16x. Okay. Questions here. What's the domain of this polynomial? All real numbers and interval notation, that is what? You got it. So this is the domain, or this is the composition, and the domain is negative infinity to infinity. Okay? All right, now, since we talked about the composition of functions, now let's make it a little bit more challenging here, and let's find the composition of 3 functions instead of 2. So we have f of x is equal to the square root of x, g of x is equal to x divided by x minus 1, and h of x is equal to the cube root of x. Let's find f of g of h of x. Okay, let's start. So f, that's an f, f of g of h of, let's make it better, this should be of x. That is equal to f of g of, and what's h of x? H of x is the cube root of x, so we're going to substitute that in here. Close it up. And now we need to find g of the cube root of x and substitute that in. So that's equal to f of, now we need to take the cube root of x, substitute it in for x here. Pause the video and give it a try. So we get the cube root of x divided by the cube root of x minus 1. That is what we get for g of the cube root of x. Okay? Now we need to find f of the cube root of x divided by the cube root of x minus 1. So now what we're going to do is we're going to take this and substitute it in for x here. Okay? So we get the square root of the cube root of x divided by the cube root of x minus 1. And that's it. That's the composition of f of g of x. Okay? Now, you can actually apply composition and composition of functions to word problems. You have real life applications. Okay? So let's look at some real life application. So an airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile. The plane passes directly above a radar station at time t equals 0. So here we have our plane is flying, and then we have it's flying at 350 miles per hour at an altitude of 1 mile, and then the plane passes directly above a radar station at time t equals 0. So this is our radar station, that's the plane at time t equals 0. The altitude is 1 mile. Okay? We want to express the distance, s in miles between the plane and the radar station as a function of horizontal distance, d, in miles that the plane has fallen. What do we have here? We have a right triangle, right? So we have to use the Pythagorean theorem. So we have a right triangle, we have to use a Pythagorean theorem. So S would be equal to, we're going to call that f of d, right? Because it says express the distance s between the plane and the radar station as a function of the horizontal distance d. So f of d, that's going to be equal to the square root of 1 plus d squared. Remember from the Pythagorean theorem that 1 squared plus d squared is equal to s squared. And we're solving for s here. So, and we know it has to be positive, not negative. So we just get the square root of 1 squared plus d squared, or in other words, the square root of 1 plus d squared. So this is part A. Now, in part B, we want to express d as a function of the time t in hours that the plane has flown. Remember, distance is rate times time. Distance is equal to rate times time. But we're given the rate. An airplane is flying at a speed of 350 miles per hour. That's our rate. So that means that our distance is just, which we'll call g of t, right? Because it says express d as a function of the time t in hours. So we're going to call it g of t. That's equal to 350 times your time. So that's g of t. Now, in part C, we want to use composition to express s as a function of t. So notice that s is in terms of d, g is in terms of t. So if we want s to be in terms of g, we need to do a composition of functions. So f of g of t is equal to, that's going to be equal to s of t. That's equal to f of, part B, we found g of t was 350t. And then in part A, we have that the square root of 1 plus d, remember, which is the distance we found in B, that is 350t, but remember to square it. Okay, so squaring 350t, we get the square root of 1 plus 122,500 times g squared. Okay, there you go. So now we know how to combine functions and get new ones. We talked about the sum, the difference, the product, and the quotient, and then we talked about composition of functions and how to find the domains of all of them. Have a good one.